Experiment number 3, vectors. The first thing is to understand the difference between a vector and a scalar. A scalar has magnitude but no direction. A vector has magnitude and direction. An example of a scalar would be the speed in your car. You're going 30 miles an hour, 30 miles an hour. The speedometer does not tell you which direction you're going. But if you say 30 miles per hour due east or due north, then that's a vector. In other words, a vector has magnitude and direction associated with it. Another example of a vector would be force. Your weight, 150 pounds, and the direction is downward. So it has magnitude and direction. On the other hand, interestingly enough, kilograms is not a vector. It has magnitude but no direction. But in the metric system, you want to talk about the vector, your weight is measured in newtons. And so you take your mass in kilograms and you multiply by 9.8 meters per second squared. So it's like 70 kilograms, 154 pounds, times 9.8 meters per second squared. That comes out to about 686 newtons, N-E-W-T-O-N-S, named after Isaac Newton. Now this particular experiment has 3 problems. And here you need both algebra and you need a little bit of trigonometry. Now in the lecture part of this course, we'll talk about the trigonometry and a little bit of algebra. But I'm just going to go by that. So there'll be another video concerning the algebra and trigonometry. So in the book it says we have 2 vectors, one vector going east and the other vector going north. Well, what I'm going to do on the board is I'm going to make a vector to represent these. And this one says 50 pounds due east. Well, first of all, what I'm going to do is going to say east goes this way. If it's going in the plus x direction, then this would be west. East, west, this is north. Maybe I should make that bigger, north. And down here, this would be south. Now we represent the vector. You can't write 50 pounds on a piece of paper, but you can draw something which is 50 pounds and represent it, and I'll represent that by a vector about this long right here. And that's going to be 50. And then the 100 pounds going north would be twice as long. Now the way we solve this vector is to complete the parallelogram. And all that means you're going to draw a line here, like that, parallel to this line, a line here, which is parallel to the 100. So if this is 100, then this is 100. If this is 50, then this is 50. And the resultant vector goes along the diagonal. And I usually represent that by the letter R. R for results, R-E-S-U-L-T, or resultant. Now the way we find out the magnitude of the results is we use the Pythagorean theorem. A squared plus B squared equals C squared. X squared plus Y squared equals R squared. X is 50. Y is 100. And that's equal to R squared. Now getting out your calculator, 50 squared should be 2,500. 100 squared should be 10,000. Now check using your calculator, make sure I'm not making any mistake. And you add these 2 numbers together, and this comes out to be 12,500. Now once we know that R squared is equal to 12,500, the way we get R is to take the square root. And getting out your calculator, putting in 12,500, and then take the square root of that number, it's 111.8 pounds. Now, unfortunately, that's not enough because this is a vector, you have to know the direction. And so the direction here can be measured from the x direction up like this, or really wanted to, you could measure it from over this way from the y direction. But I always like to do that. And then we use a symbol for the angle, and that symbol looks like a 0 with a line through it, but it's actually the Greek letter theta. Now I had a Greek student one time, she said, realize theta. But I'm from Philadelphia, so I always say theta. I'm gonna say theta. That's what she said. Now you need to know a little bit of trigonometry. Now if you go back to the lecture class, the sine of the angle would be equal to the opposite 100 over 100 would be 100 divided by 111.8. That should be about 0.89. Not particular. Now there's a sheet of paper you're going to receive in the lecture part of the course where you can look up the value of the angle if you know the sine of the angle is 0.89. And when you do that, you find out that this angle comes out to be about 60 degrees. It's actually about 63, I think. But you go check on me on that, okay? Now you have to use sine. The sine is the opposite, S-I-N, S-I-N-E, but S-I-N is the opposite over the longest side, which is called the hypotenuse. So 100 divided by 111.8, it's about 0.89 as I recall. You look it up though. And the angle comes up to about 63 degrees. Now another thing you're going to hear in the lecture class is about the cosine. The sine, cosine, and the tangent. Those are the three things we need mainly for this class. Well, the cosine of the angle, cosine of theta, would be the adjacent. Over the hypotenuse. Now, what do you mean by the opposite? Well, the opposite is the opposite. The longest side is called the hypotenuse, and this side is called the adjacent side. So it's going to be 50 over 111.8. Now, I think that's about 0.45, but I'll put a question mark there, and you look that up, and you find out the angle still comes up to about 63 degrees. The third function that we need to be able to use in this class, lab and lecture, is the tangent. Well, the tangent is the opposite divided by the adjacent. So the tangent would be the opposite divided by the adjacent. That's going to be 100 divided by 50, and it comes to be 2.0. And again, you look this up on your calculator or on that sheet of paper that you're going to be getting from me, and that comes about 63 degrees. So the answer to this problem is you need both the magnitude and the direction. So the actual answer here would be written this way. R be 111.8 pounds, angle 63 degrees, north of east. North of east. And I always put a little arrow over the R. That means it's a vector. Now there's the magnitude, and there's the direction, and you have to be very careful about the north of east. In other words, we're going up from the east towards the north, and that's 60 degrees there, 63 degrees. If we go this way, that would be 27 degrees, and that'd be east of north. So I always like to use this one right here, and I know that causes confusion, and we'll be getting into that in the lecture part of the class. And that is experiment number 3.